And I'm gonna move on to time series data or time series analysis. All right. And let me summarize all the things that we learned so far. And we did, we did machine learnings and regressions and classifications and dimension reductions, and we did the artificial neural net or deep learnings or CNNs or autoencoders and GAN. All, let me see, dimension reductions and maybe generative models as well. And if you remember, all the things there is based on, I would say, snapshot type data. What do you mean by that? Just that have single image, then the networks do something. It's gonna say, I'm gonna tell this is cat or this is dog and things like that. Or for generative models, from single noise, it's gonna generate something. Okay. So the idea is that if I show the cat image first, and the next network's gonna tell this is cat. Right after that, I'm gonna show you another cat image. It's gonna say cat, right? The sequence of the image that I'm going to show the networks doesn't matter. The sequence does not matter because what we did is that it's gonna take the snapshot type of informations or data as an input. But let's, in order to motivate the importance of time series or sequential data set, I'm going to show you the movie clip. You guys can see what I'm trying to say. Let me show you again. So think about the time when the goalie is gonna fell down to stop the ball. Let me show you again. Okay, now, because I guess the goalie has some cameras to perceive to take the image data set, right? And let me show you this one again. So, suppose each sec is gonna take the image. Suppose, then the ball was here. In the next sec, it was here, and it was here, and then from these sequence of information or sequence of data, we can easily participate or anticipate in the next near futures the ball is gonna be here, right? So what I'm trying to say is that here, if you have a sequence or information or sequential data set, we can predict what's going to happen in near future. But in this case, it doesn't matter. Okay? So, sequence matters. Sequence matters. Right? And if you remember the data set that we have, say this date, and what I'm trying to do is that now we have another axis, we want to add another dimension, which is time in this case. So in each time index, I'm going to have some kind of data set. It could be, in each time instance, it could be images. Right? So in the same data set, if you shepherd the sequence, that it's going to be totally different data set. Okay? So sequence matters, but the issue is that, or the motivation is that we haven't learned anything, any artificial neural net, which is like can deal with sequence. So that's kind of the thing that we're about to do. So let me see the time series data set or sequence first. And what's the sequence? And probably like the sentence, or is like you have different sequence. If you have change the sequence, it's gonna express different meanings. Or the medical signals and speech waveforms and vibration measurement. And we have all the time index. Like here, time and number of samples or number of times and times. Right? Those are the example of sequence that we can see. And the most of real-world data set is time series. Think about it. Think about it. You can find tons of different applications or systems. It's gonna generate the time series data set. That's why, that's the motivation that we have to know. We have to understand what time series is, and we have to learn how can we treat, how can deal with sequential data set or sequential informations. Here in this course is how can you build up the deep learning models. Okay? Use the past and present measurement or data or observations to predict the future. I mean, that's kind of the general explanations, and let's think about more like mathematical representations. Yeah, the first one is a deterministic, and the second one is a stochastic. So deterministic, stochastic time series data set. So there are many different ways that we can categorize, but here I use that I have the first group is a deterministic, and the second group of time series data set is a stochastic, and I'm gonna show you what's the difference that. I mean, deterministic, say like we have the first time index, and this is the first or zero time index, and like the first, I don't know, it's starting from zeros, okay? So they represent the time index and the corresponding values at is 1 and half and quarters, things like that. This is one way that we can represent time series data set. And another way that we can use another closed form like this. I mean, these are the same. We can write the closed like mathematical expressions to represent time series data set like that. And probably like something that you guys learned from high school, right? Another thing is that we use a linear difference equations with the initial conditions. So this is the initial conditions that we have, and now we have we represent the relationship between the consecutive data points. From here, I know that y1 is 1/2 y0s, and this one is initial conditions, and so it's half. Since we know the y at 0 and y at 1, and what's the y at 2, is that another relations, and now it's half, that's why I have things like that. So one of the example of linear difference equations, okay? And we can write all the high order linear difference equations. We can have many of them. And there are many ways that we can represent time series data set, but remember, all of them are deterministic, right? There is no uncertainty on it. All of them are deterministic. And another group or categories is a stochastic. We have more randomness on it, we have more uncertainties, we have more noise on the time series data set. And like this. And another example is like that. And we can treat it like a lot of noise on it. Right? But the thing is that we don't know which I mean, these, how do I say, okay? So y of t is measured, and suppose x of t is original, and n of t is noise added. So we are not able to separate. We are not able to separate it. In the stochastic time series data set, we have another thing. Is the one is that stationary, and the other one is non-stationary. What do you mean by stationary or non-stationary is that the mean and the variance, if the mean and the variance do not change over time, we're gonna say this is a stationary stochastic time series data set. Like this. We have a lot of noise added, but over time, probably the mean is like about 0, and the variance is like about the same, right? So we assume that the original data set does not change over time. We call it stationary, but it looks different over time because the characteristics of noise on it. Okay, so we call it stationary. And on the other side is non-stationary, as you can see here. Probably over time, the mean or variance change over time. I mean, these are kind of the definition that we have. Deterministic or stochastic. Under the stochastic, we have stationary and non-stationary. That's kind of definition that we have. So how can you deal with non-stationary time series data set? Probably like all of them say it might have linear trend. Okay. And nonlinear trend. I'm not sure it's polynomials or exponentials, but we have some kind of nonlinear trend. And another one is like seasonal trend. It's like more periodic behaviors. In many cases, when you deal with non-stationary stochastic data set, we assume that might have linear trend, might have nonlinear trend, might have seasonal or periodic trend, and finally we add noise on it. Now we have to estimate all these unknown parameters. That's like what we did in the regression problem. Okay, so probably I'm gonna stop here. So I kind of recapped the generative or the virtual models, and I changed the gear to time series data set, and what we did is that I just show the importance of the sequence. So sequence matters in many cases, and good thing or bad thing is that most of real applications or the data that we're gonna see or you're gonna observe is the time series. So that's why we need to know definition of time series on the series data set, and we need to understand how to analyze the things. But I done with defining the time series data set in deterministic and stochastic sense. And in next time, I'm going to show you why let me show you. How can we how to start to analyze the time series data set. So next time, okay? So I'm going to stop here. Before that, any questions? Okay, so I will stop. You guys can go.